docked if we hold.
Back ground for the same touch now, hopefully.
They're not seeming to care about it. Here we go, booster what? They're not seeming to care about it on the tech feed, but and we can confirm and touchdown.
Good morning, everyone. On your screen is a live view of our Falcon 9 rocket as it awaits its 11:13 a.m. Pacific Time launch from Space Launch Complex 4 East at Vandenberg Space Force Base in California. My name is Zachary Lupin, and I'm an avionics supply chain engineer here at SpaceX.
And I'm Amanda Years, a ground systems engineer, and we're joining you from Hawthorne, California.
Welcome again to our webcast coverage for the launch of NASA's Tracers mission. Now, if you were with us yesterday, you'll know that we stood down due to airspace concerns. But we're back today for our second attempt with the good news that the range is currently green and ready to support. Now, Tracer stands for Tandem, Reconnection, and Cusp Electrodynamics Reconnaissance Satellites. Tracers is a tandem satellite mission that will study how the solar wind interacts with Earth's magnetosphere, which is the region around Earth dominated by our planet's magnetic field. And this is because becoming more important because space weather events can affect our power grids and communication satellites and create potentially hazardous conditions for astronauts.
We'll have more information about this mission in just a minute. In addition to tracers, we have 5 payloads on board today. These include the Polylingual Experimental Terminal, a NASA partnership with the Johns Hopkins University Applied Physics Laboratory that is testing an advanced space communications technology. Also along for the ride is Athena Epic, a small satellite mission serving as a pilot opportunity to pathfind an innovative, scalable space vehicle design to support future missions.
We also have a payload called REAL from Dartmouth and Johns Hopkins, which will investigate how the high-energy particles in the Van Allen radiation belts are scattered into Earth's atmosphere. We also have LIDE from the European Space Agency, which aims to demonstrate direct 5G broadband connectivity from LEO to small ground terminals. And finally, there's also a demonstration mission called Skycraft, which is a satellite that aims to provide seamless communication between pilots and air traffic controllers using the same VHF radios they use near an airport, but in this case, anywhere on the Earth.
For now, at just over T-minus 11 minutes from launch, both the vehicle and range are green. Weather currently has a 0% probability of violation. If for any reason we have to call a hold on today's launch, a backup opportunity is available tomorrow at 11:13 a.m. Pacific Time.
Now, today's primary payload, of course, is Tracers, a pair of spacecraft that will investigate an explosive and mysterious process that occurs throughout the universe, from black holes to nuclear reactors, which is called magnetic reconnection.
Now, tracers will study this process around Earth to understand how the Sun interacts with our planet's protective magnetic shield, which is called the magnetosphere.
Now, using instruments designed and built by the University of Iowa, the twin satellites will measure magnetic reconnection a record-breaking 3,000 times, helping scientists better understand and prepare for the effects of the Sun on Earth.
Here's a brief overview of the Tracers mission.
Tracers consists of 2 satellites flying in tandem in low Earth orbit, designed to understand the effects of magnetic reconnection in deep space on Earth's atmosphere.
Magnetic reconnection is an explosive feature of energy that occurs when Earth's magnetosphere, a protective bubble shielding our planet from cosmic radiation, is impacted by the solar wind. Highly energized particles hurtling towards Earth at over 1 million miles per hour. This causes powerful streams of particles from the Sun to penetrate Earth's atmosphere, which can negatively impact our power grids, communication systems, and satellites.
Society today is becoming increasingly dependent on technology, so we need to understand the risks that the Sun and its influences pose to our technological infrastructure in order to keep society safe and functioning.
At the University of Iowa, we built and designed the spacecraft's instruments to do something that has never been done before: attempt to measure magnetic reconnection more than 3,000 times. Together, the 2 spacecraft will create a data set that will be key in helping scientists understand how the Sun's activity can affect our planet and create space weather.
Earth and near-Earth space is a big, complicated, time-varying system. Tracers is one of the sort of early demonstrations of how you can use multi-spacecraft technology to get a picture of how things are changing, how things are moving, how things are evolving.
So not only will it get a global picture of reconnection in the magnetosphere, but it's also going to be able to statistically study how reconnection depends on the state of the solar wind. This is going to really help us understand how to predict space weather in the magnetosphere.
Such a fun mission to be launching today. Now, while we wait for that clock to tick closer to T0, let's learn a bit more about our launch vehicle. There's Falcon 9 on your screen, a 2-stage rocket that is 229 feet tall and getting ready for liftoff in just about 8 minutes from now. Now, at launch, it produces more than 1.7 million pounds of thrust. The bottom section of the rocket, the first stage, or the booster, is powered by 9 Merlin engines. Now, those engines will burn for the first couple of minutes of the flight, carrying Falcon 9 through the thickest layers of Earth's atmosphere. Now, if you've ever watched a launch in person, you'll know that the vehicle doesn't go straight up. Early in flight, Falcon 9 performs a gravity turn, a smooth pitch maneuver that tilts the rocket sideways to build up horizontal velocity. And you may hear that called out about 10 seconds after launch as vehicle pitching downrange.
Once the first stage completes its portion of the mission, it shuts down and separates. A staged rocket like Falcon 9 sheds the booster to eliminate the weight and uncover the Merlin vacuum engine on stage 2. To reach orbit, the vehicle needs to go fast, hitting an orbital velocity of about 28,000 kilometers per hour just to keep from falling back to Earth. That's fast enough to lap the Earth in about 90 minutes or fly from New York to here in Los Angeles in under 10 minutes, about 7 times faster than the fastest airplanes. Now, after stage separation, today's booster will be landing back at Vandenberg Space Force Base at Landing Zone 4. This particular booster will be returning to Earth for its 16th time. Now, the second stage will take over from there, powered by a single Merlin vacuum engine, also known as the MVAC for short. With its extended nozzle and optimized design, the MVAC drives maximum performance in the vacuum of space. Today, we'll ignite that engine 4 separate times before deploying the final payload into orbit.
And topping off the rocket stack is the payload fairing, which is a 17-foot wide carbon composite shell that protects the satellite during the uphill trip through the atmosphere. And good call out there. Now, about 3 minutes into flight, both halves of the payload fairing will separate and parachute back down to Earth. And if recovery goes to plan, the fairings will be pulled from the ocean and prepped to fly again on future missions. So much of what makes Falcon 9 remarkable happens in flight. We have stages separating, the first stage landing itself back on land or on a drone ship in the middle of the ocean, fairings parachuting back, all ready for another flight to space. Every part of Falcon 9 is part of a larger design that comes together to do one thing: escape gravity. And that is the first step in building our multi-planetary future. Now, coming up next in the countdown, the transporter erector, or TE, will begin to retract away from Falcon 9. The TE is that large truss structure you see standing next to the rocket. It's hinged at the base and connected to the launch mount beneath the first stage.
Now, coming up, the clamp arms around the second stage will first open away from the vehicle, and then the TE will pivot backwards, slowly swinging away from the rocket. It will achieve full recline by the T-3 minute and 40-second mark. Now, throughout this process, you may also hear the TE referred to as the strong back. This is the same structure, just a different name.
And
Thanks for pressing for strong back retract.
And good call out there. Now, the TE does a lot more than lean. It rolls Falcon 9 out to the pad, raises it vertical, and stays connected through the final seconds up to launch. It also provides fuel, power, telemetry, and command connections between ground systems and the rocket.
The clamps at the top of the vehicle help to stabilize the second stage during fueling, and they also...
Strong back retract started.
There's that call out for strong back retract start. So the clamps at the top also prevent movement in high wind conditions, and once they are open, the rocket is fully free at the top. Right now, both stages are nearly fully loaded with about 1 million pounds of propellant, and this includes RP1, a highly refined kerosene, and liquid oxygen chilled to over 300 degrees below 0 Fahrenheit.
Now, through those clouds, you can just make up those clamp arms that have retracted away from the second stage, and now you can see the strong back retracting away from the vehicle. Now, propellant is loaded late in the countdown, and that's intentional. Colder propellants are denser, and denser propellants mean more performance out of the same tanks. The colder it is, the more mass you can move. Before any of that propellant flows, though, the plumbing and engines are chilled down, and that prevents thermal shock and boil-off when the ultra-cold liquid starts moving, and you may hear that referred to as engine chill.
Propellant load will wrap up in 2 steps. The first stage will finish around the T-3 minute mark, and the second stage will finish about a minute later. At this point, you've probably noticed those white clouds venting around the rocket, and that's condensation. So again, as that liquid oxygen is warming up inside of the tanks, it will boil off, and we will vent that gas overboard to maintain nominal pressure in the tanks. When that cold oxygen gas hits the warmer outside air, it condenses into the clouds that you're seeing on screen. And this is the same principle as seeing your breath on a cold morning, just on a much bigger scale.
Now the tanks are also...
Stage 1 LOX load is complete.
And there's that call out for Stage 1 LOX loading completion. Now the tanks are also pressurized using helium, and that helium is chilled too, so it stays compatible with the cryogenic plumbing. During flight, that pressurization helps force propellant into the engines as the tanks empty. Now at T-minus 60 seconds, Falcon 9 will enter startup, and at that point, the rocket's onboard flight computers will take over. From there on out, the countdown will be fully autonomous.
Just inside of the T-minus 2 second mark, the 9 Merlin 1D engines will ignite, and once they're at full power, Falcon 9 will lift off the pad and begin its climb to orbit. As of right now, the satellite remains healthy and the rocket is tracking no issues. Weather continues to remain green and the range is clear to support our scheduled liftoff at 11:13 a.m. Pacific time. So with that, Falcon 9 is nearly fully fueled, approaching startup, and heading into the final seconds before launch.
Now you may have also noticed...
Stage 2 LOX load is complete.
And there's that call out for Stage 2 LOX loading completion. So at this point, Falcon 9 is now fully loaded with 1 million pounds of rocket-grade kerosene and oxidizer. Now you may have also noticed the rocket isn't quite as shiny as it was in the past, and that's because of the soot layer present on the skin of the rocket, which is caused by the booster descending through Merlin's exhaust gases during the entry burn. And as the booster accumulates more flight history, more and more more of that soot gets deposited onto the vehicle. Now, coming up shortly, we'll hear that call out that Falcon 9 is in startup. As I mentioned, this is when the rocket's onboard flight computers will take over and the countdown will be fully autonomous. We should be hearing that call out in just about 8 seconds from now.
Falcon 9 is in startup.
And there's that call out that Falcon 9 is in startup, and in just a few moments we'll hear the final go, no-go from the launch director, or LD, for today's mission.
LD is go for launch.
And fantastic news there from our launch director. We are go for today's mission. So let's sit back and watch as Falcon 9 takes the Tracer's mission to space.
T-minus 30 seconds. T-minus 15. T-minus 10. 9, 8, 7, 6, 5, 4, 3, 2, 1. Ignition. And liftoff. Go SpaceX, go Tracers.
Vehicle is pitching downrange.
At T plus 30 seconds and counting, Falcon 9 has successfully lifted off from Space Launch Complex 4E. After clearing the tower, we now tilt or gimbal the engines to initiate a roll maneuver, which you may notice here in that Stage 1 camera view.
Falcon 9 power and telemetry are nominal.
Now this enables the vehicle's antennas to stay in the best position for communicating with the ground. Now, coming up next, the vehicle will pass through max Q, which is the point of maximum aerodynamic pressure.
Vehicle is supersonic.
And the engines will throttle down ahead of this to reduce...
M1D chamber pressure is nominal.
To reduce load.
Max Q.
And there's that call out for max Q. Now the Merlin engines are back at power and we're out of the throttle bucket. From here on, even though velocity is rapidly increasing, the atmospheric density is decreasing, resulting in less loads on Falcon 9. Now the rocket typically needs to go about 17,500 miles per hour horizontally in order to avoid gravity pulling it back down to Earth. Now, coming up shortly, we're going to hear callouts for a series of events happening in quick succession. This will be MECO, followed by stage separation, then the stage 1 flip, followed by second engine start 1, and then the boost back burn. We should be hearing all of these callouts here in just about 20 seconds from now.
Main engine cutoff.
Stage separation confirmed.
MVAC startup.
Stage 1 boost back startup.
And there we heard callouts for the successful main engine cutoff, stage separation, saw that stage 1 flip, second engine start 1, and the boost back burn. Coming up next will be the fairing deployment on the second stage. Both halves of the fairing flying today are flight proven, with one flying for its 14th time and the other for its second time. They'll be picked up today by our West Coast fairing recovery vessel.
Separation confirmed.
And we heard fairing separation is confirmed. So the boost back burn on the first stage is still ongoing, and we expect shutdown shortly.
Stage 1 boost back shutdown.
And there was confirmation of a boost back burn shutdown.
We're currently at T+3 minutes and 40 seconds into today's mission. And coming up next, we'll hear the call out for the first stage entry burn on the Falcon 9 first stage coming up in about 3 minutes from now. And you'll be able to follow along with that relight with the graphics along the bottom of your screen. Now, Falcon 9 is the first orbital-class rocket capable of reflight. Reusability allows SpaceX to refly the most expensive parts of the launch vehicle, which in turn drives down the cost of going to space. It's key to lowering the cost of spaceflight, which enables more investment in critical scientific research. And that makes missions like today's possible for more organizations and more often. Now, the first stage that is supporting today's mission is flying for its 16th time. It previously supported NASA Crew 7, CRS-29, PACE, Transporter 10, Transporter 13, EarthCare, NROL 186, and 8 separate Starlink missions. But while this booster is on its 16th trip to space, we're working towards qualifying our fleet of Falcon boosters and fairings to support 40 missions each. And for those following along, we're currently at 29 flights of a single Falcon booster, which is absolutely phenomenal. Increasing Falcon's flight count provides valuable information on repeated reuse, which is a critical element for making life multiplanetary.
Now, as a reminder, the 9 Merlin engines on Falcon's first stage are optimized for sea level, and they can achieve around 190,000 pounds of thrust during ascent and descent. Now, compare that to the single MVAC engine you see on your screen. This achieves around 220,500 pounds of thrust in a vacuum state. During entry burn, Falcon 9 will decelerate by firing its Merlin engines, but the vehicle is still moving really fast. Now, as Zach mentioned, this causes the vehicle to fly through Merlin's exhaust gases, and this deposits the layer of soot on the vehicle's surface, giving Falcon 9 that flight-proven look.
Now, coming up next, we should be hearing that call out for the entry burn of the Falcon 9 first stage in just about 10 seconds from now.
Stage 1 entry burn startup.
There's that confirmation of entry burn startup. If you take a look in the lower left-hand corner of your screen, you can see the engine status. 3 of those 9 Merlin 1D engines will fire for the entry burn.
Stage 1 entry burn shutdown.
That's a short burn. Entry burn has shut down. So coming up next will be the landing burn. And this is the final burn to slow the vehicle down even more and make that precise landing. Great view of Falcon 9 first stage coming back.
Stage 1 FTS is saved.
And we utilize both the Merlin engines throughout these various return re-entry burns, as well as the grid fins to stabilize the booster.
Stage 1 transonic. Stage 1 landing burn.
Stage 2 terminal guidance.
Stage 1 landing leg deployed. Stage 1 landing confirmed.
Stage 2 FTS is saved.
And a beautiful landing for this booster, marking the 16th flight of this first stage.
Yeah, absolutely beautiful landing here, Amanda. Now, in the meantime, Falcon 9's second stage is continuing its first burn of the mission, and we expect it to shut down just after T plus 8 minutes. And as a reminder, the MVAC engine on the second stage will be completing 4 separate burns today
Nominal orbit insertion.
before we deploy all spacecraft. We also just heard that call out for nominal orbital insertion.
So at this point, the second stage is going to embark on a coast phase, and that will last about 40 minutes before the MVAC engine relights for a second time at the T plus 51 and 8 second mark. So we're going to take a pause here and leave you with some space jams, and we'll see you back here at T plus 49 minutes for second engine start 2.
there and look at a rocket from Mars, and you just boggle the mind and mind and mind and mind. And the technology caught up, didn't it?
Welcome back to our live launch coverage of the Tracers mission. If you're just joining us, we had an on-time liftoff at 11:13 a.m. Pacific time, followed by successful ascent, stage separation, entry, and landing of the Falcon 9 first stage, as well as the completion of the first burn of the second stage MVAC engine about 8 minutes after launch. Now everything with the rocket and payload looks healthy, and the vehicle is currently flying over the Indian Ocean near Madagascar. Now, as a reminder, we're planning to have 4 separate burns of the MVAC engine on the Falcon 9 second stage before all payloads are deployed. And we're now approaching the second burn to reach the orbit needed to deploy the first spacecraft. Now that burn will be pretty brief and will last just about 3 seconds. We should be hearing a call out for that burn in just under a minute from now.
Nominal orbit insertion.
And there you heard it, confirmation of good orbital insertion. So as Zach mentioned, we have 4 deployment events today. And the first will be BARD, which is expected to occur at the T plus 54 minute and 32 second mark, just a few minutes from now. This will be followed quickly by deployment of the real payload. As we count down to that first deployment event, let's learn a little bit more about these payloads. BARD is York Space Systems' mission to flight demonstrate the polylingual experimental terminal, an advanced communications technology developed in collaboration with the Johns Hopkins Applied Physics Laboratory and NASA's Space Communications and Navigation Program. The terminal is designed to enable real-time interoperability between government and commercial satellite relay networks. It's a first-of-its-kind capability as NASA shifts towards a commercial satellite relay communications architecture.
And the other payload being deployed here is REAL. Now, REAL will help us better understand how the high-energy particles in the Van Allen radiation belts are scattered into Earth's atmosphere. REAL is led by Dartmouth College in collaboration with Johns Hopkins Applied Physics Laboratory, Montana State University, and Boston University, and is funded by NASA's Heliophysics Division, and is being launched as part of NASA's CubeSat launch initiative in coordination with Maverick Space Systems Incorporated. We should be hearing callouts for deployment of these 2 payloads in just under 2 minutes from now. Now, as a reminder, these 2 payloads will deploy about 20 seconds apart from each other. once these payloads deploy, we'll then have 2 additional burns of the Falcon 9 second stage MVAC engine, followed by our additional deployment events. And that'll, of course, be the 2 tracer satellites, Athena Epic, Lyde, and Skycraft.
York Space Systems BARD separation confirmed.
And great call out there for payload deployment of the BARD mission. We're now waiting for confirmation of the real payload.
Real separation confirmed.
And great news there with REAL also being deployed. And with that first successful deployment, we're going to take a short break before the next event, which will be the second relight of the Merlin vacuum engine. So we'll see you back here at about T+1 hour and 4 minutes. Welcome back to our launch coverage of the Tracers mission. If you're just joining us, we had an on-time launch at 11:13 a.m. Pacific time, followed by successful ascent, stage separation, and 2 burns of the second stage engine.
We also saw our first payload deployments today, BARD and REAL. Now, there are a few more major milestones coming up before we complete today's mission, and that is, of course, 2 additional MVAC relights and deployment of the remaining payloads from Falcon's second stage.
That's right. The second stage Merlin vacuum engine is going to start and shut down 2 more times before those deployments begin. So let's listen in for the callout and watch for SES-3, which will be a very quick 1-second burn. We should be hearing that call out in just under a minute from now. Now, as a reminder, we'll have 1 more burn of the MVAC engine, and then that'll be followed by our additional deployment events, and we'll be deploying 2 tracer satellites, Athena Epic, Lyde, and then Skycraft.
Nominal parking orbit.
Good call out there, and that 1-second burn completed successfully. So with that, we're going to take another break before we come back for second engine start 4, and then the next payload deployment, which is expected around the T+1 hour and 34-minute mark. In the meantime, enjoy the views.